We're going to be looking at another topic. This is our topic 2, number system. Number system is a very simple topic in mathematics. Okay, so first of all, we'll start from I would like to draw this number system. I have this. Okay, these are sets of numbers. We can call it number system, or some people will call it sets of numbers. Okay, these are sets of numbers. If you watch, this one is called complex number. This one is called complex numbers. This one are called real numbers. These ones are called rational numbers. This one is called irrational number. Okay, this one is called integers. This one is called whole numbers. This one is called natural numbers. While this one is called prime numbers. So I'm going to explain all of them one by one, because their definition is paramount to what we are doing. So, complex numbers are those numbers that are made up of two parts, both the real part and the imaginary part. Then, under complex number, we have real numbers. Now, what are real numbers? Listen. Real numbers are numbers that can be found on the number line. I repeat, real numbers are numbers that can be found on the number line. Yeah. What do you mean by number line? We have something like this. The center is 0. We have plus, minus infinity. We have here plus infinity. All the numbers that can be found on this number line, like we have -1, -2, up till infinity. Here we have 1. We have 2 up to plus infinity. All these numbers are called real numbers, meaning that any number you can think on earth is a real number, apart from complex number. Remember that complex number, we say it's numbers that has two parts. The real part and imaginary part is presented as something like this. So this one is the real, while this one is the imaginary. So numbers that come up like this are called complex numbers. But in this number system, we are not interested in these complex numbers. We are interested in the real part of it, which is this. We are not interested in the imaginary part of it. Now, coming to what the real number is, which is the real part of it, we say that there are numbers that can be found on the number line. So, from plus infinity to minus infinity. So, these parts from here down are called the real negative, while from here down are called the real positive. So, we have real positive, we have real negative. Numbers that can be found on the number lines are called real numbers. Then the next person we are seeing here is, if you observe, real numbers are now parted into two. We have the rational number and the irrational numbers. Rational number and the irrational numbers. Now, under the rational number, we have integer. What are integers? What are integers? Let's see. Integers. Now, see, let me take this example. Remember that we have this. We have minus infinity plus infinity. So we have like -1, -2, and so on. We have 1, 2, and so on. So when you talk about integers, listen, let me bring it to a layman's standard. Those things you call digits, they are called integers. Those things you call digits, like someone say, please, you know, when we talk about digits, we are not talking about calling numbers as words. We are talking about calling numbers individual. Example, someone met you on the one and say, please, instead of asking you to give him your phone number, he said, please, can I have your digits, your phone digits? That means he's trying to tell you that these numbers you're going to call for me, call them one by one as individual numbers and not as a collective number. That's why you now say 0, 8, 0, 0, 7, 0, 3, 4, 2, 5, 1, 6, 3, 7, 8, like that. There are 11 in numbers, as you all know. So you see that we are calling those numbers one by one because we are representing them as digits and not as collective word numbers. It's not like when you want to call 1357, say 1357. That one you have called them in word. But if you want to call 1357, okay, in digits, you say 1357 digits. But in word, you say 1357. So that thing you call digit is what we call integers. So when you start picking all the elements of real numbers individually, then what you are picking is what? Integers. Now, if you observe, that means we are going to have positive integers and we're going to have also negative integers. So the numbers that make up integers are all the numbers of real, all the elements of real numbers. They are all the elements that makes up also integers. But when you're talking about a real number, you're collecting the whole numbers that are not complex numbers. Then when you're talking about integers, you are naming the elements of real numbers individually. Minus, that means minus 1 is an integer, minus 2 is an integer, minus 3 is an integer, 1 itself is an integer, 2 is an integer, 3 is an integer, 0 is an integer. Note that. Okay. Now, so integers are elements of what? Real numbers that are mentioned individually. Okay. Now, one other thing we need to know about integer is to know its property. When we talk about its property, we are trying to say whether it is closed or open under operations of addition, subtraction, or multiplication. Now, if you say a certain set of number is closed under a certain operation, example, they will ask you, is integer closed under the operation of addition? All they are trying to say is, if you bring two integers together, if you add them together, will it produce another integer? If it produces another integer, then integers are closed under the operation of addition. But when you add two integers together, it does not produce another integer, then you will say that integers are not closed under that operation. Example, I have the minus 1, I have minus 2, I have okay, let me take a set of integer. I have minus 2. Okay, let me start from one because it's coming from very far place. Then minus 1, minus 2, minus 2, minus 1, 0, 1, 2, and so on. Okay, I believe you understand what I've done here. Now, I want to check whether this thing is closed under the operation of addition. If I decide to pick minus 2 plus minus 1, pick them accordingly. Minus 2 plus minus 1 will give me minus 3. Minus 3 is an integer. What if I do 1 plus 2 will give me 3? 3 is an integer. So if I add two integers, no matter how I add them, it will always produce integers. So I can now say that integers are closed under the operation of what? Addition. And if you do them for subtraction, if you do minus 2 minus 1, which will give me minus 2 plus 1, which will give me 1, it will also produce integer. So you see that integers are closed under the operation of addition, they are closed under the operation of subtraction, and they're also closed under the operation of what? Multiplication. Hence, you can say that integers, they are closed under the operation of addition, subtraction, and what? Multiplication. They are not closed under the operation of division. They are not closed under the operation of division. Note that. They are not closed under the operation of what? Division. Because if you divide two integers, you will not get an integer. When you divide two integers, you will not get an integer. Okay, so that is about integers. I've explained about integers. Remember, I'm picking them from here. I've explained about integer. Now, from this integer, now, permit me to come back to this rational number. What are rational numbers? Rational numbers are ratios of two integers. Rational numbers are ratios of two integers. And what we mean there is that when you bring an integer, let's say 2, and you divide and you put this and you put, like, let's say 3. This is an integer. This is an integer. But in this case, we are not saying 2, 3. We are saying 2 over 3. And 2 over 3 is a number on its own, is an individual on its own. But they are made up of ratio of 2 integers. So when we have ratio of 2 integers, we call them rational numbers. When we have ratio of 2 integers, that means if I have A over B, where A and B are elements of what? Integers, then this expression is called a what? A rational number. So rational numbers are said to be ratios of 2 integers. Ratios of 2 integers. But one thing you must know is that the denominator, that is B, must not be equals to 0. Why? Because if this is equals to 0, 2 over 0 is not a number. If you press your calculator, it will give you what? Math error. So when you are talking about rational numbers, ensure that the denominator should not be equals to what? 0. The denominator should not be equals to 0. So we have rational numbers, elements that are made up, or numbers, set of numbers that are made up of two ratios of 2 integers. So when you have ratio of 2 integer, you will refer to that as a rational number. Now let's look at the properties of these rational numbers. Now they are closed under the operation of addition, multiplication, subtraction, division. Rational numbers are closed under the operation of addition, multiplication, subtraction, and what? Division. Okay, we have seen this. We have seen this. We have seen this. We have seen this. Let us look at this guy. This one is called a rational number. A rational number. What are irrational numbers? Irrational numbers are just numbers that are not rational. Simple. They are numbers that are not rational. There is no other definition for them. Now, which set of numbers fall under these irrational numbers? The set of numbers that fall under these irrational numbers are numbers that are in their short form and numbers that are constant. These are the most important members of this system. That's the irrational number. Numbers in their short form and numbers that are constant. Let's look at numbers in their short form. Now, do you know that when we say a number is in this short form, it is a number that does not have a perfect square? Example, what do I mean by a perfect square? If I have root 9 is plus or minus 3. If I press root 9 in my calculator, it will give me a perfect number, which is not going to be a decimal. Unlike if I press root 5 in my calculator, my root 5 will definitely give me, according to what you see in your calculator, 2.236, let me say approximately 2.63, 2.2361. This is root 5. You see that this root 5 does not give me a perfect answer. It gives me number in decimal form. So when I take the root of a certain number and it does not give me a whole number, let me use that word, a whole number like this, rather it's giving me a fraction, that number is in its short form. Hence, this one is not in a short form. Why this one is in its short form? And we say that numbers that are in their short form are referred to as what? A rational number. That is one. Also, another member of this set is constants. When you study sciences, we have some constants. We have Planck constant. We have mathematical constants like pi. Let's take example, pi. Pi is a constant. And pi is 3.142 according to, if you see it as 22 over 7. Okay, so you see pi is a constant. But pi is seen as irrational. So don't get yourself confused. 22 over 7 belongs to rational because it's ratio of 2 integers. Whereas 3.142 is irrational because it is a constant. So that means pi is an irrational number, while 22 over 7 is a rational number. But then in mathematics, they'll say, take that pi is equals to this. Until you approximate 22 over 7, you cannot see pi. So that's why in your calculator, there is a key for pi separate. And there is a key for 22 over 7. You can do that with other keys. Okay, so that becomes pi. Okay, so if I'm to list out the elements of irrational numbers, so I can always say that some elements I have there, I can have root 5, it's a short form. I can have root 3, it's in short form. I can have pi, it's a constant. Let's look for one or other constant that I can have lambda, which we call the decay constant, which is 0.693. Remember that in your chemistry. So it's 0.693. So it's a constant. So these are elements of what? Irrational number. Now, I want you to see something. Did you know that when you take the roots of prime numbers, it gives you irrational numbers? Let's take something. First prime number is what? 2. First prime number is 2. Huh? Okay, let's take root 2. It's an irrational number now. It's a short form. What's another prime number? 3. Root 3. It's another irrational number. Another prime number, 5. Root 5. You see, root of all prime numbers belongs to irrational numbers. Note that. So if they ask you that in the exam, you should know where that question is actually coming from. So we have seen this, we have seen this, we have seen this. We all know what whole number is. Okay, let's look at n. N is called natural numbers. N is called natural numbers. We already know what whole number is. N is called natural numbers. What are natural numbers? Listen, natural numbers are also referred to as counting numbers. Natural numbers are referred to as counting numbers. These are numbers that are countable. Now, look at the notation you're using so you don't get confused. When you were little, you were in school, your class mistress or master, in fact, it's mistress because now women they teach that level of children. Now, they always ask you to bring okushi bottle, that is a bottle cover, and maybe stone or whatever it is that you use in counting. And when you get to the class and we are doing arithmetics, they will say count 2, 1, 2. Count 3, 1, 2, 3. Add them together, 1, 2, 3, 4, 5. Now, that the mistress is asking you to count 2, 3, and so on because they are counting numbers. If they are not counting numbers, he or she will not ask you to count that. Now, that means natural numbers are counting numbers. What do we mean? Any number that is not a counting number is not a natural number. 1/2 is not a natural number. Why? Can your teacher ask you to count 1/2 or count half? If your teacher cannot ask you to count that at that level of education, then that is not a natural number. So natural numbers are also called counting numbers. And if you observe, if natural numbers are called counting numbers, you see that natural numbers will belong to the set of real positives, or you say positive integers. Because if you come to number line, these are negative and this is positive. We have like -1, we have like -2, and so on. Here we have like 1, here we have like 2. Remember that this is real positive, this is real negative. And also remember that the whole of this is also called positive integers, and these ones are also called negative integers, positive integers. Now, if you observe, -1, -2, and so on cannot form natural numbers because they are not counting numbers. Nobody can ask you to count -1. Nobody can ask you to count -2. But if you observe from here now down, they are all counting numbers. That means the elements that will make up a set of natural numbers are all real positives. And or you say positive what? Integers. So if I'm to write out some examples of natural numbers, so I'm going to be having, we have 1, 2, 3, and so on. All these are counting numbers. Okay, so I believe you understand what we say. So we have seen complex numbers, real numbers, rational and irrational numbers, integers, whole numbers, natural numbers. Now, talking about prime numbers, we already know what prime number is. These are numbers that have how many factors? 2. Means that they can be divided by 1 and themselves. So they have 2 factors. The total number of numbers that can divide them, it must be up to 2. That is why 1 is not a prime number. Why? Because 1 can divide 1, and there is no other number that can do that work. So 1 has only 1 factor that can divide it, so it's not a prime number. Assuming it has only up to 2 numbers that can do that job, then we can say that 1 is a prime number. So 1 is not a prime number. Prime number start from what? 2. Okay. Now, natural numbers are closed under the operation of plus and multiplication. You can check on that. Natural numbers are closed under the operation of addition and what? Multiplication. Okay, so these are all we have seen about number system, and this is what was taught to you in your class. Now, there is something I want us to observe here. Real number is contained in complex number. Do you see that? Real numbers are contained in complex numbers. Now, rational number intercept, rational number union, irrational number will make up real numbers. Watch that. Rational number union, that is, rational number union, irrational number is equals to real number. Hope you know that. Rational number union, irrational number is equals to real number. Now watch that now. You see that integers are contained in rational numbers. Integers are contained in rational numbers. Whole numbers are contained in integers. If you check the whole of integer, you see that you have whole numbers. Now, if whole numbers are contained in integers, then integer is a kind of universal set to whole number. Now, you see what? Natural numbers are contained in whole numbers. Natural numbers are contained in whole numbers, while prime numbers are contained in natural numbers. Prime numbers are contained in natural numbers. So from the smallest to the biggest, P, N, W, Z, Q, R, C. So P is contained in, like that, like that, like that, like that, and so on. So if we are to write out this as a matter of set theory, this can now be written out as a N is contained in Z, is contained in Q, is contained in R. You see that? N is contained in Z. We just remove this. We just remove this. If you do that, you see that N is contained in Z. Z is contained in Q. Q is contained in R. Why are we removing these two? These are the two that when you come to number system, the university wants you to concentrate on just these ones that have not cancelled. And if you watch, you see that N is contained in Z. Z is contained in Q. Q is contained in R. You also note that Q union Q prime, na im be R. Q union Q prime, na im be R. So that is all we need to know about number system. Now, lastly, about number system, operation between sets of numbers is what I call this subtopic. Operation between sets of numbers. Now, if we have something like N intercept Z is equals to what? Now, N intercept Z is equals to what? Now, for you to know this, use this method. When intersection, okay, also if you have N union Z is equals to what? Let's solve these two examples. This is intersection, this is union. When intersection is the operation between these the two number system, then the lower set will become the outcome, or you can say the lower set will win. But when it is union, the bigger set will win. So N intercept Z, I will now ask myself, if you draw out this, you see that R is bigger than Q, Q is bigger than Z, Z is bigger than N. That means N is smaller than Z. So if intersection, the smaller one will win. Out of N and Z, which one is the smallest? N is smaller than Z. So the final answer here will be what? N. Now, N union Z. If it is union, the upper one will win. That is the bigger one. Z is bigger. So the final answer here is Z. So please use that method. So N intercept Z is N, while N union Z is Z. Use that method to always know that. So the next thing we are going to do is to go to questions and past questions to see the questions that has been asked so far under this topic. So we move to much has not been asked. Much has not been asked. So first of all, I will take question that was asked in the plasma tutorial mock exam, their first interim mock exam. Let me start from there. So I have this question says, this one says N union Q intersect Q prime is equals to what? Now look at this question that was asked in plasma tutorial mock exam. N union Q intersect Q prime will give us what? Now I'm going to be taking the 2. I will solve for this. Whatever answer I get for this will now union intercept this. Do you get that now? So what I'm going to do now is N union Q. N union Q. Remember, we have that our set of numbers. We have to write it out somewhere. You have to write it out somewhere that N is contained in Z, is contained in Q, is contained in R. So I will be following it. N union Q, union, the higher one. So N and Q, which one big pass? Q big pass N. So Q will become the outcome here, then intercept Q prime. Now, if you observe Q intercept Q prime, don't be fast to say Q and Q prime. Which one is more? Remember that Q intercept Q prime. Remember we already said that Q union Q prime is R. So Q intercept Q prime. There is nothing relating Q and Q prime. It's going to be an empty set. So the final answer here is empty set. There is nothing in that Q and Q prime has in common, but their union will give you a real number set. So that becomes the answer. Final answer there is a empty set. That is one question from there. Let me see if there's another question there we can. Another question will say the set of X such that X is equals to P over Q, where P, Q are elements of Z. They say, what is this? X such that X is equals to P over Q, where P and Q are elements of Z. Remember that Z is an integer. That means P is an integer, Q is an integer. Then P over Q will give us the answer to this thing is going to be what? Rational number. The answer of that thing is going to be what? Rational number. Ratio of 2 integers. P and Q are integers. Ratio of 2 integers. I think that is that were from plasma tutorial mock exam. So let's see the past question. In 2021, we have question number 1 there. 2021, we have question number 1. 2021, it says 2021 to 2022. Okay. Let's look at 2020. Okay, question number 1, section B. Question number 1, section B. There's question number 1, section B there. Okay, if you look at question number 1, section B, say let N, Z, Q, R represent a set of natural numbers, which are integer, rational number, real numbers, blah, blah, blah. Then I said the order of their inclusion is, look at it, this is the order of this, what they want us to answer there. I'm saying the first question from the past question, which is question 1, section B. I've showed us that the order of inclusion is what we said I showed there. Now we'll go to question number 8, the same section B. It says the set of natural numbers are closed under what operation? Set of natural numbers. Remember that we have said that sets of natural numbers are closed under the operation of addition and what? Multiplication. So they are closed under the operation of addition and multiplication. Then the next question there is, we'll go to 2022-2023, which is question number 1. And that is one of the most challenging questions in that year exam. So the question is trying to say which of these is false. But let's look at what they are saying first. They have that A is -6 is an element, okay. A -6 is an element of Q. B 11 is an element of P. C pi square is an element of R. D root of 9 over 4 is an element of Q prime. Then E 3 pi is an element of Q prime. Now let's observe and treat this question one by one. Let's start with this. There is something I didn't actually tell us, but let me use this question to say it. Now, remember that we said that, let's take an example like number 2 now. Let's take 2. This 2 is a whole number, true or false? True. It's a whole number. This 2 can also be classified as a natural number, true or false? True. This 2 is a real number, true or false? True. This 2 is an integer, in fact, positive integer, true or false? True. But can this 2 be classified as a rational number? Remember, rational numbers are ratios of 2 integers. From what we have learned before, you may say no. But I want to tell you that yes, because all integers are rational numbers of themselves. What do I mean by that? All integers can be divided by 1 and still remain themselves. Example, if I say 2 over 1 is still simple as 2. That means if I call it 2 over 1 and someone call it 2, they are still saying the same thing. But then, if you are seeing it as 2 over 1, it is going to be a rational number. If you see it this way, it's going to be a rational number. But when you see it this way, it's going to be only an integer. Do you understand that now? So every number can be divided by 1, and that number remains itself. So every integer is a rational number of itself. So bringing that knowledge here, minus 6, is it an element of rational number? Yes, because minus 6 over 1 is a rational number, though minus 6 is a negative integer. So this is true. This is true. Let's look at this. 11 is an element of prime number. Yes, 11 is a prime number. Why? Prime numbers have only 2 factors. That means there's only 2 numbers on this earth that can divide them. The first number is 1, and the second number is themselves. 11 divided by 1 is 11. The only number again that can divide 11 on this world is another 11. 11 divided by 11 will give you 1. Every other number in this earth cannot divide 11. So 11 is a prime number, which is true. Pi square is an element of real number. True. Remember that real numbers are numbers that can be found on the number line. That means all numbers on earth are all what? Real numbers. You also remember that real number is split into 2. We have rational and irrational. Is it not true? So these 2, if you bring them together, will give you a real number, of which this guy is part of it. This guy, which belongs to this one, is part of it. So this is an element of real number. True. Now let's look at this. Is this true? We have to first of all simplify. This is simple as root 9 over root 4. Hope we know that. Root 9 is equals to plus or minus 3. Root 4 is equals to plus or minus 2. If you take the modulus of these 2, you have 3 over 2. 3 over 2 is regarded as rational number and not a rational number, because irrational numbers are numbers in their short form. This is not a number in its short form. This thing also means 3 over 2. So this is actually a rational number and not an irrational number. Do you get that? So this is false. This is the first false I'm seeing. Now looking at this, 3 pi is an element of irrational. Remember that irrational numbers are made up of constants and numbers in their short form. So when you say 3 pi, that means pi times pi times pi. Hope you understand. Once it is pi, they are all irrational numbers. So this is true. So the answer here is option D. I believe that was one of the most challenging questions when we come to number system. And that brings us to the end of number system. We'll go into another